Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Dear students, this second video lecture of week 6 is the continuation of my previous first video lecture of week 6 for the course Biostatistics 1. In the first video lecture, we have learned about quantiles for ungrouped data. Now, in this second video lecture, today we are going to learn about quantiles of frequency distribution. So, in this video lecture, we are going to learn quantiles for group data and its graphical representations. Now, the graphical representation of
these partitions, values, quartiles, deciles, and percentiles. From the definition of median, that is the middle point in the axis frequency distribution curve. It is divided the area under the curve for two areas having the same area in the left and in the right. From this may be divided the area under the curve for 4 equal area, and this is called quartiles. In the same procedure, divide the area for 10 equal pieces of area is called deciles. Finally, where divide the area for 100 equal pieces of area is called percentiles. So dear students, this is the symmetric distributions of the data, frequency distribution shape of the data. So these are the frequencies, and you see over here, if we divide the data into 4 equal area number 1, 2, 3, and 4. So this line divide the data, this line also divide the data, and this line also divide the data. So the value at this position is called Q1, value at this position is called Q2, and Q2 divide the data actually in two equal parts. So this Q2 actually called the median. Now this is Q3 and this is the fourth area. So Q1 the first quartile, Q2 is the second quartile, Q3 is the third quartile, where A1 is equal to A4, A1 is equal to A2, A2 is equal to A3, and A3 is equal to A4. These three numbers Q1, Q2, and Q3 divide the data into 4 equal area. So this is the graphical representations of the quartiles. Now the graphical representations of the deciles. Deciles are 9 numbers which divide the data into 9 equal area. Area number 1, first part, area number 2, area 3, area 4, area 5, area 6, area 7, area 8, area 9, and area 10. You see over here D1 is the first decile, D2 is the second decile, D3 is the third decile, D9 is the 9 deciles, and these all areas are equal. A1 is equal to A2, A2 is equal to A3, A3 is equal to A4, and so on. This is equal to A10. This value at this position is called D1, and this is the first part, the first area of the distributed data. So you see over here, these 9 numbers divide the data into 10 equal areas. These 9 values D1, D2, D3, D4, D5 up to D9 divide the data into 10 equal areas. Similarly, the same procedure for division is done for finding percentile for any frequency distribution curve. P1 will be the first percentile, P2 will be the second percentile, P3 will be the third percentile, and similarly P99 will be the 99 percentile, where all the area A1, A2, A3, A4 up to A100 will be equal. To find the quartiles, deciles, percentiles, we follow the same procedure to find the median. First of all, arrange the data in ascending form only. First of all, arrange the data in increasing order, and then as we use the procedure for the median, like use the same procedure according to the median, we can find the quartiles, deciles, and percentiles. If numbering arrangement of quartiles, deciles, and percentiles is fraction, then its value is for the number greater than it. A true number, the value is the mean of its and the greater numbers. Now you see over here, for example, this is a very interesting example, and from these examples, dear students, you will learn how to find the quartiles, the deciles, and percentiles from the ungrouped data and from the grouped data. These examples are now very clear and simple to find the quartiles Q1, Q2, and Q3 from this data. And I have already told you about the procedures of quartiles, but there are different procedures. There are different procedures for the positions of Q1, Q2, Q3, and similarly for deciles and for percentiles. You can use any procedures. Uh, so to find the Q1, Q2, and Q3 from this data 20, 30, 25, first of all, arrange the data. You see over here, I arrange the data in ascending order 20, 22, 23, 25, 30, 32, and 36. Now, first of all, find the position of this capital Q1. Q1 is the first quartile value. Q1 represents the first quartile value. So first of all, find the position and the value of the position of the value. First of all, find the position of the value. So there are n is equal to 7 odd numbers. This small q1 represent the position of the value. So q1 is actually 1 by 4. 1 by 4 multiplied n. 1 by 4 multiplied n. So we can find the position of the first quartile by this 1 by 4 by n. Similarly, 2 by 4 by n the position of q2. 3 by 4 by n the position of q3. And you see over here in the in the previous slides that we can find the positions of the deciles, quartiles, like d2, 2 into n plus 1 divided by 10 if the number of terms n odd or even. We can use the position value for d2, 2 into n plus 1 divided by 10. For d3, 3 into n plus 1 divided by 10. Similarly for q1, n plus 1 divided by 4, n 2 into n plus 1 divided by 4 for q2, and 3 into n plus 1 divided by 4 for q3. Now we can also easily find for the position values by using this expression 1 by 4 multiplied n for the position of q1 value. So this small q1 actually represent the position of the capital Q1. So 1 by 4 multiplied 7, which is equal to 1.75, and 1.7 approximately suppose equal to 2. So at this position number 2, the quartile Q1 lies. So at the position number 2, we obtain 2. Now for the second quartile, first of all, find the position. 2 by 4 multiplied n. 2 by 4 multiplied n. So 2 by 4 multiplied 7. 1 by 2 multiplied 7 means 3.5. And 3.5 approximately round about, suppose this is equal to 4. You can easily find to round up this number 3.45 to 4. So the position of the Q2 is 4, and at the 4th position we obtain 25. So this is the Q2. Now Q3. 3 plus 1, 3 divided by 4 multiplied n. 3 by 4 multiplied by 7, which is equal to 0.25, and 5.25 approximately equal to 6. So the position of the third quartile is 6, and at the 6th position 1, 2, 3, 4, 5, 6. At the 6th position we obtain 32. So there, this is the quartile 3 values, 32. Now another example to find the quartiles Q1, Q2, Q3 from the data when the number of terms is odd. The number of term is even. You see over here in this example, first of all, arrange the data in the ascending form. 18, 20, 22, 23, 25, 30, 32, and 36. So first of all, find the position for the value Q1. Position for Q1, 1 by 4 multiplied n, 1 by 4 multiplied 8. There are 8 terms, so we obtain 2. Now this is the whole numbers. So when the number of term is even, then we can find the position of the first quartile by means of second terms and third terms. The second term is 20 and the third term is 22. So divide by 2. 20 plus 22 divided by 2, we obtain 21. Now similarly, for Q2, for quartile number Q2, the position is 2 by 4 multiplied n, 2 by 4 multiplied 8, and this is equal to 4. And now this 4 mean that the value of the position of Q2 is the mean of fourth term and the mean of fifth term. The mean of fourth and fifth term. The mean of fourth and fifth term. So the mean of 4 in fifth term, 1, 2, 3, 4. Fourth term is 23 and fifth term is 25. So 23 plus 25 divided by 2, 24. So the Q2 value is 24. Similarly, for quartile number 3, first of all, the position of the value 3 by 4 multiplied n. So this is equal to 6. And 6 mean position mean of 6th term and 7th term. The 6th term is 30 and the 7th term is 32 divided by 2. So the Q3 term is 31. So dear student, in these two examples, note that if the number of term is odd, then you can easily round the position to the whole numbers and pick the number at this position. You will easily calculate Q1, Q2 and Q3. But if the number of term is even, then first of all calculate the position value, and this two the position value, this two represent the mean of second and third term, 4 represent the mean of fourth and fifth term, and 6 represent the mean of sixth and seventh terms. Now another example, to find the quartiles Q1, Q2, Q3 and group distribution data. You see over here, these are the columns 50 to 69, 70 to 89, 90 to 109, 110 to 129, 130 to 149. And these are the given frequencies you see over here, 3, 7, 4, 4 and 9. In the form of group, first of all, write the real boundaries, continuous the boundary 50 to 69, 70 to 89. So these are the discontinuous data. So first of all, continuous the data, find the real intervals. For the real intervals, subtract 0.5 from this upper lower limit and add 0.5 to the upper limit. So subtract 0.5 to 50 and add 0.5 to 69. We obtain 49.5 to 69.5. And now subtract 0.5 from 70 and add 0.5 to 89. You see over here, these are the real intervals, and I have already told you about the procedure of real intervals. For the real intervals, for the continuous interval, subtract 0.5 from this start limit and add 0.5 to this final limit. So you will obtain the class real intervals. Now find the cumulative frequency. For the cumulative frequency, write 3 as it is. 3 plus 7, 10, 10 plus 4, 14, 14 plus 4, 18, and 18 plus 9, 27. So this is the procedure for the constructions of the table. For quartiles, first of all, write the construct the real limits and then cumulate frequency. And at the second step, find the arrangement number of the quartiles to find quartiles interval 1. So for the quartile interval 1, for the position value 1 by 4, 1 by 4 multiplied n multiplied 27, these are a total 27 numbers. So we obtain 6.75. The interval of the quartile 1 is have the cumulative frequency 10, and this formula Q1 is equal to A plus Q1 minus N1 divided by FQ into C. In this formula, A is the real lower limit. You can put here small l, but we can represent this by any number, by any variable. Suppose A. A represents the lower limit of the class interval. This is the lower limit. And this N1 is the cumulative frequency of the previous interval of the quartile interval, which is equal to 3. And you see over here in this example, this is the cumulative frequency of the previous interval. And FQ is the frequency of the quartile interval. Frequency of the quartile interval is 7. And C is the length of the quartile, step size length of the quartile. Actually, these are 20. Now, putting the values in this formula, Q1 is equal to 69.5 plus 60.75. You see over here 60.75 actually represent the arrangement number of the quartiles. Now 69.5 plus 6.75 minus 3 divided by 7 multiplied 20, which is equal to 8.2. Now to find the Q2, find the arrangement number of quartiles to find the quartile interval number 2. First of all, find the quartile interval number 2, the position values. For Q2, 2 by 4 multiplied and 2 by 4 multiplied 27, which is 13.75. So the interval of the quartiles number 2 is have the cumulative frequency 14. In the previous slide, you see over here the cumulative frequency for Q2 is the cumulative frequency is 14. The cumulative frequency is 14. You see over here the cumulative frequency is 14. Now the interval of quartile number 2 is have the cumulative frequency 14. So 89.5 plus 13.5 represent 13.5 represent the small q1. You see over here in the formula, and n1 is the frequency. N1 is the frequency, which is equal to 10. Now divide by, you see over here n1 is the cumulative frequency. The cumulative frequency for 14 is 10. For 14 the cumulative frequency is 10. So for 14 the cumulative frequency is 10. Divide by 4 multiplied 20, which is equal to 0.107. Similarly, for the arrangement number of quartiles, to find the quartiles interval number 3, Q3 is equal to 3 by 4 multiplied and 3 by 4 multiplied 27, which is equal to 20.25. So in this formula, this small q1 is now 20.25, and 20.25 for the 20.25 the class lower class interval 129.5. This is the 129.5. And why we select this class? Actually, the Q3 position is 20, and 20 lies in this cumulative frequency. Similarly 13 lies 13 lies in this cumulative frequency. 13 lies in this cumulative frequency. For 13 lies in this group. So for the 14, 10 is the cumulative frequency, and now 20 lies in this group. So the cumulative frequency is 18. Now putting, this is the cumulative frequency, this is the lower limit of the class, and this is the small q3 values, and now this is divided by 9. Divide by 9 mean the frequency of the class multiplied the class interval. So 134.5 is q1. So you see over here, these are the examples. And for in this example number 1, then for this group data, first of all we obtained q1, and for q2 we obtained 107, and for q3 we obtained 134.5. So q1 lies in this class, q2 lies in this class, and q3 lies in this class. Now to find the decile D1, D5, D8 of the following data, first of all arrange the data, and we have the 7 terms which is odd, and these are the ascending order. For D1, first of all find the position for D1. 1 over 10 multiplied 7, which is equal to 0.7. In 0.7 around about to 1, so at the first position d1 is 20. Similarly d5, for d5, 5 by 10 multiplied n, which is equal to 3.5, and 3.5 approximately equal to 4. So this is d5 is a 25. At the fourth position we obtain 25, and at the eighth position, the value of the position number d8 is 6. 5.7 actually round about to 6. So at sixth position we obtain 32. Now decile d5, d1, d6 and d8, from this data we can find these from this for these procedures. Now in the group distributions, to find d1, d5 and d9 from this group distributions, first of all write the real intervals, subtract 0.5 from this limit and 8.5 to this limit, and continuously you can find the real interval of each class. This is the given frequencies and this is the cumulative frequency. So for d1, first of all find the arrangement number of the decile. To find the decile interval d1, 1 by 10 multiplied n, which is equal to 2.7, and 2.7 lies in this group. So at this class d1 lies. So putting the values, a is the lower limit of this class 14.9, 49.5, and d value is the 2.7. Similarly, n1 is the cumulative frequency. The cumulative frequency of this interval will be 0, and the frequency of this group is 3. So divided by 3, we obtain d1 is equal to 69.5. Similarly, you can find d5 and d9. And you see over here, d1 lies in the first group, d2 lies in the third group, and d9 lies in the last group. To find the percentile, for the percentiles we can use the same formula. For example, P8, P50, P85. P8 mean 8 divided by 100 multiplied 7. In this data we have 7 odd numbers which is equal to 0.56, and this is approximately equal to 1. So at the first position, percentile number 8 is 20. And for the percentile number 50, first of all find the position. 50 multiplied by 100 multiplied n multiplied 7, 3.5 approximately equal to 4. So this is the 50 percentile, which is 25. Similarly for the P85, you can find the position. The position is 6, and at the sixth position we obtain P85, which is 32. Now you see over here, these are the same procedures. And for the group distribution data, how to find the percentiles. P8, first of all find the arrangement number of percentiles. To find the percentile interval P8, 8 by 100 multiplied n, which is equal to 2.16, and 2.16 lies in this interval, in this group. So this is the in this frequency, cumulative frequency 2.165 lies. So a, the lower limit of this class is 14.9, and the P8, the arrangement number of the percentile is 2.16, and n is the cumulative frequency. The cumulative frequency is 0, and the actual frequency is 3, and the class interval you see here is 20. So P8 is 69.5. And similarly we can find P50 and P85. And you see over here, P8 lies in the first class, P50 lies in the third class, and P85 lies in the last class. So to find the percentile arrangement of 115 in the above data, you see here percentile formula: P is equal to A plus P small p minus n1 divided by FP n2 C. In this example, the percentile arrangement is 115, and this is equal to 109.5. Actually, 115 is equal to 109.5 plus x. This percentile P1 percentile arrangement is unknown. So suppose this is x minus 14 divided by 4 multiplied 20. So this x after simplification is 15.1. Then percentile arrangement is 15.1 divided by 7 multiplied 100%, which is equal to 56%. So percentile is a measure used to indicate the value below which a given percentage of observations are all Let's call this p%. For example, 100 minus p%. The 90 percentile is the value below the 90% of the observations may be found. Percentile is a value below which a certain percentage of observation lies. Data set, for example, 2, you see over here. What is the percentile rank of 10? The percentile rank of any number 10, number of values below divided by n multiplied 100. Number of values below 10, 16, there are total 10 terms. Below 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Below 10 there are 16 numbers. And divide by total numbers multiplied 100, so 80%. The percentile rank of 10 in this data is 80%. So dear students, you see over here quartiles D1 is equal to P25, Q2 P50, Q3 P75. Similarly, decile D1 P10, D2 P20, D3 P30 and so on. D9 is equal to P90. So dear students, in this last one example, I would like to tell you about this example to find the percentile arrangement of 115 in this above data. P is given that the percentile arrangement to find the percentile arrangement of 115. 115 is the percentile, but the percentile arrangement is unknown. So in this formula, this P represent the percentile arrangement, which we represent by the small p. In the previous example, you see over here small p1, p1, p2, p3 and so on. So actually in this example, the percentile arrangement is unknown. So putting 115, the percentile, and the class interval, and the small p value is missing. Putting the value of n114, frequency is 4. You see over here 115, 115, and now x is equal to 15.1. And now this is the end of this segment. Thank you. Allah Hafiz.